Hello, everyone. My name is Clayton Fritz. I would like to welcome you to today's webinar, Is Mapping the Basics Still Worth It? And look at how mapping impacts the mining cycle. In this webinar, you're going to learn about the different types of mapping, when and why you should map, how mapping data is needed throughout the mining cycle, and how to use the latest mapping tools to your advantage. Our presenter today is Maureen Moore. Maureen is a senior geologist and training program lead with our technical services department and manages the Maptek training program for our North American region. Maureen is incredibly knowledgeable and passionate about mapping, as it plays a crucial role in every mining operation and at every stage of the mining cycle. All right, just a bit of housekeeping before we get fired up. First, today's webinar will include a few poll questions. You can answer those simply by selecting your choice on the screen and then clicking submit right below the question. If at any point in the webinar you do have a question, please type that into the chat box located in the chat panel at the top right-hand side of your screen. Also, you will receive a link to the recording of this webinar by email in case you'd like to watch it again, and it will also be made available on the Maptek website at a later date. All right, and now I will hand it over to Maureen.
Thanks, Clayton. Mapping plays such a crucial role in every mining operation and at every stage of the mining cycle. So crucial, in fact, that without proper basic mapping techniques and practices, an entire operation could be risked to fail. At Maptek, we recognize that these high stakes translates to a lot of pressure for the geologists and engineers. So during this webinar, I will discuss the connection between mapping, lithology, structure, alteration, mineralization, and the success of your operation across the mining cycle. So let's quick look at the topics we're going to cover today. So we'll discuss industry challenges, mapping styles, what, when, and why, the importance of collecting mapping data. We will also discuss how technology can be integrated with classic techniques. And then we're going to open it up for a question and answer session so we can discuss the stuff that we're talking about. So hopefully you guys, as you were going through, you can review some questions that you might have. Okay, we're going to kick off this webinar, like Clayton mentioned, with a few polls for us to understand more about your background and current workflows. So our first poll, we'll go ahead and issue that, is, are you mapping? So take a few moments and answer whether or not you are currently mapping. Alrighty, so now let's go ahead and look at the results. So it looks like almost over 60% are actually mapping, which is great. So hopefully you'll learn some new techniques, things to pick up on, and then that almost 40% that are not mapping, hopefully this webinar will help introduce why or some techniques on how to do that. So now let's take one more poll before we get started. So when you are mapping for those 61%, what are you actually mapping? Lithology, structure, alteration, mineralization, or other? And other could be ore calls or variety of things. Alrighty. So it looks like we have a variety of things that you guys are mapping. So we have lithology and structure, really important. Not many people are looking at alteration, and then mineralization seem like it's important. So we'll go over some examples throughout the presentation, but those are the basics. So if you ask, we ask, do you think it's still important to map the basics? We'll discuss that even more throughout the presentation, but that's what we're speaking about. Okay. Over the years, mapping techniques, purposes, impacts on the downstream mining cycle, and the importance of this data has fluctuated. As a result, a lot of the basic mapping techniques are forgotten or just pushed aside. Since working with Maptek, I've had the opportunity to work with a lot of mapping clients, and here is kind of a summary of what you might see. So we have a lot of people that are conducting maps, we're generating maps, but maybe they're just not being used, or maybe they don't know how to use them or how to utilize them, or maybe they collect the wrong data or not enough data. And then you have a group of people that just don't see the value in mapping. So in my opinion, they're missing out on a lot of data and they're not optimally classifying or characterizing their observations in a systematic way. And that can really put your operation at risk. All right, now we're going to look at the different styles of mapping. And so we're going to go through, and this is kind of more or less the order when you would see the different mapping. So we have greenfields, baseline, brownfields or near mine exploration, production geology, geotechnical cell, blast hole or muck, infrastructure, and environmental. And you'll notice that a lot of these fall under what we would call geologic mapping. So we will focus on that in the presentation. Next, we want to think about what is the mining cycle? What are the stages? And as an economic geologist, I'm always trying to understand where am I spending my money and where am I potentially making money? So in the mining operation where you're extracting the material, that's where you have the potential to generate money. All these other stages, you're probably just spending money. So although most of our effort in mapping is focused on the production environment, we do have other areas where we could be saving money or bringing more value with the money that's being spent. Oh, right. So, like I mentioned, we do have a lot of the styles of mapping is focused around geologic mapping. And this is normally happening during the exploration and mine environment stage. And the basics things we're mapping are going to be structure, lithology, mineralogy, and alteration. When we're looking at the rock types, we're trying to understand what was the time sequence, what was the spatial relationship. Structure, we're trying to understand what were the structural settings? Are there faults, fractures, veinlets, and what are their density? This will help us understand how the fluid has flown through the rock and where and what ore fluids potentially. And alteration helps us understand what happened as the ore fluid flew through the rock. And more importantly is what was left behind, because that's what we're most likely trying to extract. Okay, so we now are looking at greenfields mapping. So this form of mapping, we are focusing on, do we have an ore target potentially there? You are normally going to be looking for new target areas. So it's going to be an area where you maybe don't have a lot of mining operation. The ground is most likely potential for a location for similar deposits of its nature. So you're focusing on what is that ore deposit and what is the impact on the mining cycle there? Well, if you do a great map like this map over here, this paper map example, lots of detail, then it could indicate that you have potential for an ore system that could be economical to mine. Or you could just say, yep, this is a lot of really cool rocks and pretty minerals, but nothing that will be realistic to mine downstream. So the map that you produce here is normally very detail oriented. And with that, it's great, but some of the stuff here it's kind of hard to read on a paper map. So it'd be really nice to bring this into a shareable platform so that information can be used downstream. The next thing we're going to be looking at, or another type of map, is a baseline map. So here we are looking at large scale sampling and collecting of operations. You hopefully will be using your exploration mapping into the baseline mapping. And how this impacts the mining cycle is that it's essentially helping you understand what is there before the mining operation starts. So this could really aid in the reclamation process after the mining has ceased or discontinued, as well as your environmental mapping. So brownfields exploration is also named as near mine exploration. So this is where we are looking at what often is phrased as the shadow of the head frame. So you're looking at the mine that you're operating in the ore system and the ore genesis, and trying to understand what are the signatures you're looking for, and you're trying to identify if that potential exists outside the targets you already know. So the impact on the mining cycle here is that you could potentially expand the life of your mine. You could also mitigate risk and understand if that's even a possibility. So that really, really helps the local community, the mining company, and also if you're able to successfully mine material, it can help with the local environmental as well. Okay, so now we're getting to the production geology where we're going to spend a little additional time because we do have a lot more examples here. This is where we normally are using the mapping information to generate money. And so there's going to be more examples and more benefits here and impacts to the mining cycle. So here we have production geology. We have two main environments, open pit and underground. If we do not get the details of the material classification right, we could be affecting our mining operation by misrouting and not properly blending. Here's a great example of what you would expect in an open pit paper map example, where you have some high wall information here, really good information. Again, it'd be really nice to have that in a shareable platform so that you can hide all that detail when you need to, but then use it for geologic models, resource modeling after. So here's another example of an open pit digital map example. Now we're going to go into the underground environment, and here's a great example of a classic paper map example. Again, great detail, but if I can't survey or quantify that data or link it to things, it's just a note. Whereas if I put it on a shareable platform, I'm able to actually really use that information in downstream processes. So here we have a good example of how when we integrate paper mapping into a shareable 3D platform, we're able to see that detail, see the imagery, and draw conclusions on what we're seeing without seeing all of the detail. So it's really, really nice to be able to do that. And we'll talk about some more opportunities as we go with the other types of mapping. So here we have geotechnical cell mapping. In this mapping, we're focusing on measuring and recording rock fabrics. So we're trying to understand what are the structures, lithocontacts, faults, bedding, all that information, rock material types and stuff, to understand, okay, what are the different properties that we're working with. And when we do cell mapping, we're going to be dividing them up into equal divisions with defined by a height and width. And we're going to classify the different groups of the structural orientations for our process. So this is really important. And if we don't do this correctly, we're going to put our entire team in danger, as well as really put our operation at a high risk. So here's another great example of the digital geotechnical cell mapping, where we have the different groupings as different colors, and we can break those out, connect it with a forecasting model if we wanted to. So lots of good uses here. Next, we're going to go into our blast hole or muck, depending on what environment you're in. And this is usually where we kind of skip to the ore waste characterization. So we're assuming, again, at this stage, all along the way, we should be reviewing the previous maps because it's going to give us more information. And here at this stage, we're basically just trying to make sure that we are correctly classifying the material. And if we don't, it's going to hit our bottom line really quickly, as we are going to probably misroute the material, which is going to affect our recoveries, mill returns, and planning overall. So this information can really, really be used in forecasting and for planning purposes. So, that's another great impact to the overall cycle and to mitigate your risk. Oh, right. So here you will see my example. We're missing an infrastructure map. So this is a very nice, sad panda who's upset that there's not a lot of maps out there. So infrastructure mapping, although it's not really geologic mapping and is often forgotten, it can really, really be critical to the process, as well as can put you guys at risk. So if you don't understand where your water, electrical, gas lines, or old mine workings, you're going to have voids, which I think anyone in the production environment probably has in a story or two. So with that, you really do want to make sure that you probably have that information, share it with the geologists or engineers, and with keeping that on a shareable platform, we're able to share that across the mining cycle and departments. Another one here is the environmental. So a lot of people are probably doing environmental sampling or mapping, but it's usually later on, or if you're doing it, it's in a different department. It's really important, again, to share that, because if you don't do that, you could be putting your project and your community at risk. An example of that, as a geologist, I really like to understand where my sulfides are. Some of them are economical, some of them might be penalty elements, some of them I might be able to use for to further the metallurgical recovery process. So all that is really important, as well as when you look at the environmental impacts of some of the sulfides. So I probably have those maps somewhere. So include that in your environmental stages, and again, sharing it will allow you to easily review that information without really skipping a beat. So Like we asked earlier, do we really think mapping the basics is still worth it? If we were all talking at the same time, hopefully I'd hear some screams, but you're all muted right now. So we'll wait for the question and answer for your hurrahs or your feedback. But I think we absolutely do need the basics. And here's some reasons why. Well, if we map the basics when we're collecting geologic mapping, we can use that information across different styles of mapping and the mining cycle. And maybe your geologists, if as long as they do the basics, someone who maybe is more familiar with more advanced application of that basics can use it to make more in-depth interpretations or more decisions. So if you kind of do that systematically, it'll make it easier for everybody else, and that data is usable rather than cherry picking what you're selecting and recording, and then that data isn't really transferable across the platforms or different styles or in the different stages of your operation. And infrastructure and environmental mapping can really help mitigate your project risk. It's not as difficult, and usually it's you already probably have that information. It's just remembering to incorporate that. And remember, mapping should never go away. We just need to understand what those classical methods are and keep developing the new generation with those skills. But that next generation really likes technology. So why don't we leverage that and make sure that we are incorporating those classical techniques, boots on the ground mapping with new technology? Because I really think that's going to set us up to ride through any downturn, complex deposits, or whatever you have there.
All right. Thanks, Maureen. That was great. So as I mentioned before, please write in your questions on the panel on the right-hand side of your screen. We can have an opportunity to answer those. I'm going to see. Looks like we've got a few already. Maureen, first question is, can I import historical mapping into the new mapping? How would those two integrate?
Yes. Yeah. So when we talk about historic mapping, there's a couple of different options that you might think about. So paper mapping, like I discussed and showed here in the webinar, you would probably bring that in as an image and then pull out the important information and characterize it in a database or of sorts. And then there's other ways where you might have other platform data. So let's say you have it from a different program and you want to incorporate it all with your mine planning. We could also import that as a DXF, CSV, depending on what you're working on. And with our project work, we've had a wide breadth of data. One project we had over, many, many years, decades of data. So it really depends on what you're working with. Yeah, we can kind of go with that as whoever's question that was, we can follow up after this.
Okay, another question here. What platform are you using?
Great question. So I work for Maptek, and although this presentation was a little bit high level, I did use Vulkan for the geologic mapping and Point Studio for the geotechnical cell mapping.
All right, looks like we've got one more. How are you bringing field data into the software?
Good question. Yeah. So, like I mentioned, I get to work with a lot of really good geologists and engineers, and most of them want to either bring the data, field data at their desk. So we call it a desktop workflow. Or for other people, they want to use a tablet and they can use a stylus, their hand, a mouse, whatever, or a pen to bring that information directly in on a tablet. So we can help you kind of work through a custom workflow that's very specific to your site's needs, your deposit's needs. So, yep, we can do digital mapping there.
All right, looks like we might have another one. Which software is best for geotechnical data collection and storing in a database, Vulkan or Point Studio?
Great question. It kind of depends on what you're probably using. So most of the people that are using Point Studio are going to be using Point Cloud data. So within Point Studio, there's a lot of options to process your Point Cloud data, your photogrammetry data, and extract a lot of that data. And Vulkan has databases. So they actually work really well together. So you can collect data from Point Studio using all the great tools it has, or if you want to just enter in manually using a Brunton within Vulkan, you can also store that. And what we normally recommend is that in your database, you might have a variety of sources data, and you just want to make sure you characterize that. So if I brought it in and it's a measurement from a Brunton, I classify that as a Brunton measurement. And whereas if I'm getting some data from Point Studio's tools, then I would include that as Point Studio data. So hopefully I answered the question, whoever had that question.
Okay, perfect. And those are all the ones we have so far. And we are nearing the end of our time today. If you do have additional questions or you want to dive more in depth on anything that was covered today, please feel free to reach out to Maureen or myself directly or email support@Maptek. We would love to answer any of those extra questions, dive into anything in more depth, and help you out with whatever it is that might be. So on behalf of the entire Maptek team, thank you for attending. Have a great rest of your day.
Thank you.